For the SFT paper, actually, there are certain parts of the questions, especially in the MCQ as well as in the essay questions, are coming from the simple trigonometry and Pythagoras theorem part. So for today's lesson, we'll cover the Pythagoras theorem, what are the applications, especially even though we learned the theorem, the applications are much differ when it comes to questions, especially they are combined with the Cartesian geometry and they might ask questions, right? And for the trigonometry part, we have to learn several rules actually, right? And you have to learn how to convert the degrees and radians, right? And so on, right? If I recall the Pythagoras theorem, you just know it as stated in here like that: a squared plus b squared is equal to c squared, right? Simply saying that the area of the square on the hypotenuse is equal to the sum of the areas of the squares on the two shorter sides. So this would be the example. Here the c square is equal to a square plus b square. And as a theory, you already learn about these things. And for example, you can try to do these questions, right? The other one when it comes to the Pythagoras theorem is that if you have three values of the triangle each side, if you can apply that theorem, and if the values are okay, especially the a square plus b square is equal to c square, which means that whatever the triangle satisfied with the Pythagoras theorem, it is automatically become a right triangle, right? Which means one side of the triangle is 90-degree in angle, right? So here are some examples you can try on. And here you can see the application of the Pythagoras theorem, right? One example, a side is equal to 3, b side is equal to 4, then we can apply the theorem. C is going to be, from one side it is going to be 25, so you have to square it, which become a 5, which is a very common Pythagoras triplet actually, 3, 4, 5. So like this triplet, we have several triplets, right? Let me share one with you. So here are some other examples for the Pythagoras triplets, right? You can see 3, 4, 5 and 5, 12, 13, 8, 15, 17. All these whole numbers are actually satisfying the Pythagoras theorem, right? Giving the right angle triangle. And we can do some examples from this as well. Let me show you the examples, right? You can try to find the shorter sides uh, or the length of the next triangle side, right? And in this case, you have to always remember whatever unit you are using as for the length, the standard unit or the SI unit for the length is meters, right? Whatever the unit you are using, like if it is a centimeter, millimeter, when it comes to the Pythagoras theorem, you should always apply with the same unit. If it is millimeters, all the sides should be applied converted to millimeters. Or if it is meters, all of them should be in meters, right? That's the common sense actually. And learning this part, there's an awesome application actually. Since we have already learned this Pythagoras theorem now, can you try to find out the yes, okay. So here's actually a A-level type question that can be asked as for even for a MCQ question actually, right? If there's a cuboid like this, and let's say we want to find the length simple y, okay? We want to find the length simple y. Let me show you the length y here in red color, right? This is the y length. Actually, this is the diagonal of the cuboid, right? However, to find out that diagonal of the cuboid length, we have given several other lengths in the cuboid. For example, you can see using this if you want to find this y length, if I take the rest of the lengths, you can see there's a triangle formed as ABC, right? ABC. And now you can see the BC distance is given as 12. Okay, one side is given as 12. We don't know the other lengths, right? So in that case, so we want to find the y length, but however we have to manually calculate this x length. It is at the bottom actually. Okay. So in order to calculate this x length, you can consider the adjoining triangle ADC, this one, right? From the ACD triangle perspective, both of these triangles are have a common side AC length, right? So as you can obviously see, we have the 3 for the Pythagoras triplet. So automatically you can apply the Pythagoras theorem, and you have to make sure that this is a right angle triangle all the time. Otherwise, we cannot apply the Pythagoras theorem. So this is x become 5, and if x is 5, if it is 12, this is going to be 13, right? This is going to be 13. So that is kind of an question we can expect for the A-level exam, right? Here you can see the calculation. The idea is that we can use this Pythagoras theorem to solve questions in 3 dimensions, right? Or 3-dimensional objects. So you can again try these questions mentioned in this PDF. Okay. And here is another example, exercise 2, right? Calculate the length of the diagonals of the following cuboids, right? These are the each side, the length, width, and the height of the cuboid. So you can determine the diagonal length of the cuboid, right? And you can give the answer up to 2 decimal points. Now, recall, as I explained earlier, we can apply this Pythagoras theorem in different combinations, right? Especially, we already learned about the Cartesian geometry, the x and y axes, right? Now we have already learned that we can use it for 3-dimensional objects as well. So even it is if even it is there are 3 axes, right? X, Y, and Z axis. You can just, if there's a right angle triangle, you can apply this theorem, right? If this is X axis, then the Y axis, then there's another Z axis, right? So let's say you have several points over somewhere here. So one point can be determined using these 3 axes, right? What is the X length, what is the Y length, as well as what is the Z length. So in this case, what happened is that let's take some point in here, this point, okay? If I want to locate this point, first of all, we have the length from the y-axis, right? Then you can get the length from the x-axis, and again the length from the z-axis, right? Right. However, in this case, we will only stick to the 2-dimensional Cartesian coordinate system, right? In the 2-point Cartesian coordinate system, we are using the xy axes, right? And I think you already learned how to locate a point on the xy axis, right? As you can see, the triangle can be drawn, or you can imagine the triangle if I only give you these three Cartesian coordinates, right? So these coordinates are 3, 4, 2, 6, and 3, 4, 2, 6, and 1, 0. So always remember the first number is the axis number, then the other one is the y-axis number, right? Then if I ask you to draw or point out these coordinates in the xy coordinate system, it should be something like this, right? This is 1, 0. This is 3 by 4y, and this is 2x and 6y, right? And now you can see obviously this is not a right angle triangle, right? This is obviously not a right angle triangle. And even though, let's say if it's a right angle triangle, but it is obviously not shown, right? This is not a 90-degree angle. This is also not a 90-degree angle. And we cannot exactly say this is also a 90-degree angle, right? However, what is the use of Pythagoras theorem in this case? Why we need to use the Pythagoras theorem in the Cartesian geometry questions? Now you can see we can actually find out this length, right? You can find the length from B to C. How you want to do that? There's no right angle triangle, but you can actually use a dashed line like this. You can connect these two imaginary lines and you can create a right angle triangle, or otherwise you can use the opposite way. You can use imaginary line like this. Obviously for this case, I think much clearer one is this one, right? Now you just need to find out this distance and this distance. What may be the distance? What may be the distance in this case? So obviously, for the first, the height is going to be how much? It is a very simple way you can deal with these things. You just have to deal with the y coordinate, right? So C is in here, B is in here. So what is this distance? This is going to be, there's only 2 points, right? This is going to be 2. And the exact opposite, what is the x length? This is going to be 3, this is going to be 2, this is going to be then 1, right? So you can say this is 2, this is 1, and this is the right angle triangle. You can apply the Pythagoras theorem and find out the BC length, right? You can find out the BC length. And if you can understand what I'm saying in this case, you can use the same method to find out the AC distance as well using these two lines. The BL length can also be found using these two, calculating those two lengths, right? Well, when we learn about the Cartesian geometry lesson separately, I will introduce you what kind of equations uh, we can use without just drawing these figures. We can just apply the equations and find out the lengths. Okay, right. So that is one example application of the Cartesian geometry, right? And obviously, you can see the AB length is given as 37, BC is 5, and AC is going to be 20. And now we can determine, okay, obviously it is not going to be a right angle triangle, but we can try, right? Since we already find out these three lengths, now you can apply it for the Pythagoras theorem and check whether it is a right angle triangle, right? So for that, we'll take the two short sides, right? Which is going to be uh, 37, sorry, the 5 and the 20, right? And you can see 5 and the 20, when it is squared, the answer is actually 25. So it is not equal to the 37, right? In that case, we can say this is not a right angle triangle. Right? This is not a right angle triangle. Or you can just find out what is the answer for this one. So 5 squared plus 20 squared, which is going to be how much? 20 squared is going to be 400, right? 400 plus 25, and 425 squared, I think it is equal to, let's take a calculation. So the answer is actually 20.61, right? If you square this one, the answer is 20.61. But what is the length of the largest side? It is 37, right? So this is not a right angle triangle. Here are some other questions you can try, right? You can determine whether the largest angle is a right angle or not, actually. And here are some coordinates of this vertices, which means the triangles. And you can find out whether they are right angled or not, right? And there's another application of the Pythagoras theorem, right? Because we only learn about the Pythagoras theorem that all the squares, the square method is we already have a sense of, right? We learned that if I take the length of the C and if I create a rectangle with that exact length, these sides are going to equal, and that is how the Pythagoras theorem has been formulated. But there's another way, which is that you can actually use the semicircles, right? You can use these semicircles with the diameter, taking the diameter as per the side of the length of the shorter sides or longer sides, right? This also satisfy the Pythagoras theorem equation, right? For example, what I mean by that is that, can you find out the area of this semicircle? How to find the area of a circle? It is 5r squared, right? It is 5r squared. So since we are taking the semicircle, we can take half times 5r squared. So it is going to be, the radius is going to be how much? The length is a for the shortest side. A is equal to what? The diameter, right? Diameter divided by 2 means the radius, a to the square, right? So ultimately it gives as 5 divided by 8, a to the square. And you can take these three sides like that. And when we do the calculation, we can see that it is also very correct, right? However, we can only use the semicircles. You can remember this one as well, right? If we have a question like this for the exam, you can use it, right? And now we can learn about the trigonometry. We can just give an introduction, right? We can name the triangle into three parts: the hypotenuse, opposite, and the adjacent. So these adjacent and opposite is going to be differ depending on your choice for the angle. For example, if I consider this angle in this A side, if I consider this angle, the opposite of this angle is the opposite side of that angle is called as the opposite, right? And the adjoining angle or the length is called as the adjacent, and the hypotenuse is the largest of the, it is the largest side of the triangle actually, right? So if I create a different scenario, if I consider this side as my considering angle, what is going to be my opposite? It is going to be this one. This is going to be the opposite. Then this is going to be the adjacent, and this is always the hypotenuse, right? That is how we can name it, name a triangle. And actually there are 6 different functions we can use with this trigonometry. However, we are going to only learn about the main 3, the sine, cos, and tan functions, right? In the sine function, you can see I'm considering, so the considering angle can be written down as the theta. Theta is, the symbol is something like this, right? Theta is the considering angle we are going to consider. So in this triangle, in this right angle triangle, I'm considering this as my theta. Okay, then obviously in front of that, you can see this is my opposite, and here my adjacent, and here is my hypotenuse, right? Sine function, consider as, you can see, if I consider the sine theta is always the opposite divided by the hypotenuse. Opposite divided by the hypotenuse, you have to remember these 3 actually. The cos theta is the opposite of that. Adjacent divided by the hypotenuse, you can see adjacent divided by the hypotenuse. Tan is the exact opposite. Opposite divided by the adjacent, right? You can see there's there's a remarkable connection between these 3. You can easily remember these 3 actually, right? You have to just identify what is the opposite and what is the adjacent, like that. And let's say you have the values here, the 5, or this is 10, and with the Pythagoras theorem, let's say this is 3, this is 4, and this is 5, right? Obviously, since this is a right angle triangle. So opposite is going to be, value is going to be 4 divided by 5. This is going to be 3 divided by 5. The other one is 4 divided by 3, right? It is very easy, right? Not a big deal. So it is the exact same I have taught you so far. The opposite side divided by hypotenuse, adjacent side, opposite divided by adjacent, right? Tan theta. And this is one example you can try on. So if I ask the sine theta, what is going to be the value? It should be 12 divided by. So you have to first of all find out what is the length of this hypotenuse, right? So you can see this, if this is 5, 12, this is going to be 13, right? So sine theta is going to be 12 divided by 13. Cos theta is going to be 5 divided by 13, and tan theta is going to be 12 divided by 5. So here it is mentioned in here. Let me show you one example. Okay. In this case, you can see in the left side triangle. It's mentioned as a right angle triangle. So there's a one missing length. We can use the Pythagoras theorem. If it is 8, 6, it is the total is equal to 100. 100 squared is equal to 10, right? So this side is going to be 10 now. And with that in mind, we need to find out the sine, cos, and tan theta values, right? As I explained earlier, there are actually original 6 functions when it comes to trigonometry. The cosine, sec, and the cot theta. We actually you can there you can obviously see it is the exact opposite of the sine, cos, tan values, right? If I show you again,